Good afternoon, friends. Welcome back to 360 Digit MG. Continuing our series of discussions on the interview preparedness and what you need to be aware. All right, so we'll take it a little random. We'll try to find out what is what. Okay, let me start. Yeah, so we'll be discussing as always. We'll be discussing with the CRISP DM. We'll be talking on various things. So we'll probably jump into data mining supervised. All right. And as part of that, supervised or unsupervised, what are the things that are there? We will address them. Now, one thing you need to remember as part of your interview preparedness is that they would expect something what is known as a holistic, your holistic understanding of the entire thing. Meaning, they would probably start with one specific topic wherein we will have then they will probably start off with the EDA, then they'll move on to all the other topics and then move to the end. All right, so that is essentially what it is. So let us now start. So what I'll do is I'll start with um, like I said, data mining, and specifically within supervised today we are going to be working on. All right, and within supervised we shall be discussing about the shallow models. All right, some of shallow models and some of ensemble models both is what we will be discussing. And to start with, let us talk with the Bayesian classifiers. All right, so first question that I'm going to be asking about Bayesian classifier. So the question that was often asked is what is the principle of the Bayesian classifier, or what is the fundamental of the Bayesian classifier? So to respond to that, the to respond to that, the answer is basically it works on the principle of Bayes rule. It works on the principle of conditional probability. All right. All right. So these are the two fundamental things that is part of the Bayes rule. Okay. So obviously the question would be, what more can you talk about the Bayes rule? So you can explain this Bayes rule with the the example of either classification or prediction. The Bayes rule can work for both classification and prediction, and as that is essentially what it is. Okay. Now, what is the Bayes rule? If the question is next, what is the Bayes rule? So the Bayes rule formula is what you'd be expected to, tell about. So you can explain the probability of an outcome given a particular condition. All right, the probability of an outcome given a particular condition is what the Bayes rule is all about. Now, how do you explain a little more about that particular probability with a given condition? So there you may want to give in that as it stands, the prior probability is simply the probability associated with the prior probability is simply the probability associated with the output class. We bring in a measure of a conditional probability or a likelihood measure. So the usage of the word likelihood is important when we are discussing about the Bayes rule. Okay. Then the definitions of what is known as the posterior probability, the definitions of what is known as the prior probability, the definition of what is known as the likelihood. And then when you use the measurement, when you say likelihood, there is bound to be a question asked with reference to what do you mean by likelihood? How is likelihood different from probability? So you should be in a position to immediately respond about the differences, what is probability and what is likelihood. Okay, so those things, try to have a thorough grip on those aspects. All right, and then there is of course the how good is the Bayesian classifier? What is the advantages, disadvantages of Bayesian classifier? Why is Bayesian classifier not so popular? So the Bayesian classifier, what is the biggest disadvantage of Bayesian classifier? Now this is an obvious question, but many people miss out on this particular aspect, which is con, and that is assumes independence. Now, obviously, when you mention the statement assumes independence, all right, when you mention the statement assumes independence, immediately you are bound to be asked, says, what do you mean by assumes independence? All right. So you may want to explain with an example, all right, that the overlapping or the intersection of the bodies that is there, you may use the example of the same example that we cover as part of our curriculum, wherein we are talking about uh, the spam males and the ham males. Now, obviously, the word lottery is something that appears predominantly in the spam males, but we assume that the word lottery is going to be appearing in the same proportion of the spam as well as the ham males, which is incorrect. We have to bring in we should ignore the condition of independence and we should bring in a factor of dependence, which is not possible as far as the Bayesian classifier is. What about the advantages? All right, what about the advantages of this thing? So advantages, it is pretty easy. Because of a simple assumption, it is able to come up with the results very soon. All right, and it is very good for multi-class. Uh, 1 minute, let me just write it down. So the advantage is good for multi-class classification. All right, and it is better than models like the training set that is required for the Bayesian classifier is relatively lesser. All right, uh, and with less training data also, it is able to uh, get the logic behind it, and it is able to work behind it. And the other disadvantage of Bayesian classifier. All right, the other disadvantage of okay, let me just write it down here. So can work well with less data. One of the disadvantages of the Bayesian classifier is it is better suited for models which are categorical in nature. So this is another thing. Okay. Now, one of the important aspects that is asked in real life in interview questions is scenario based questions, wherein you will be given, we have um, a large number of fraudulent transactions and a small number of sorry, made my mistake. We have a large number of non-fraudulent transactions, and we have a small number of fraudulent transactions in my database in the ratio of probably 95% to 5%. All right, 5% non-fraudulent and you know, uh, 95% fraud is 5%. Now, what is it that we would do? All right, we need to build a classification model. What is it that you would do for this? Now, the approach for this is, all right, let us say scenario. Okay, so the approach for this is ask a question. Ask all right, what are the input variables for this data? Now, if the person is a subject matter expert, he may be able to answer, but trust me, 9 times out of 10 the person will try to evade the question, and he will say input, there are various inputs. I mean, there are so many inputs. You assume the input. All right, you assume the input that is there in this particular scenario is what he will say. So on the fly you will have to talk about, you know uh, you can probably immediately say duration. So let us assume there is something called as duration. Now, what do you mean by duration? Obviously, respond in questions which will elicit more questions from you. So duration, how long is he a customer? Okay. Now, on similar lines, we want to find out tenure of loan. All right, that is tenure of the loan period. All right, then you can say age, in case you are asked to assume. All right, age of customer. All right, now the person has asked you to build a model around this. All right, and you may be tempted to immediately say, you know what, we can build a regression model because duration, tenure of the loan, age of the person, all these things are continuous data. So regression, logistic regression model is going to be good. Or one of the most popular things is the decision tree. We can go ahead with the decision tree and you know build a decision tree model. But remember one thing, the fact of the matter is that he wants you to address this 95% and 5% imbalance. All right. So do not fail to address that. Try to address, okay, firstly, we need to address this 95%, 5%. This again can be addressed with a question. What is the data size? Now, if the data size is small, when I say small, again, it is a very, very relative term. What is the purpose? Now, if you ask him, what is, may I know the data size? He'll say, what is the purpose? Why do you want to know the data size? You tell them that if I have, let us say, 100 million records, then 5% of 100 million is a pretty good number. It is, all right. 5% of 100 million is a pretty good number. We are talking at 5 million fraudulent transactions, which obviously cannot exist. But if I have, let us say, 5 million fraudulent transactions, I will take all the 5 million fraudulent transactions because the entire data is pretty large, and I'll take an equal number of non-fraudulent transactions randomly chosen from the remaining 95% of the data, and go ahead and build any of the models. Whatever model you feel you are most comfortable, whatever logic you have, you may want to go ahead and do that. What if the answer is no, no, no? How is it possible to have 100 million transactions? We don't have such 100 million transactions. Let us assume we have about 1,000 transactions. The total number of transactions is only 1,000, which makes 5% of those fraudulent transactions as 50. Now, obviously, if I'm going to take 50 fraudulent transactions and an equal number of non-fraudulent transactions, let us say 50 non-fraudulent, building a classification model with just 100 records with such a small sample is not going to be great. So then what do? Then you go for the rule of the 70-30. You tell them that if we have data, binary categorical, binary classified data or two class data, and if the categories are in the proportion of 70-30 or closer, 70-30 or closer, it is considered to be not a imbalanced data. So we will take all the 50 records, which is the 5% of it, and treat it as the 30%. So if 50 is 30%, all right, then we can take the remaining 70% approximately. That will be about 50, 50, 100, 115 or something. 125 is what probably, or 110. So 110 plus 50, approximately 170 records. So definitely from 100 we have reached to 170 records. Probably we can do that. Or you may recommend for some synthetic minority oversampling. All right, now obviously you will have to know about this synthetic minority oversampling and the methods. What is synthetic? What is SMORT? SMORT is synthetic minority oversampling. I'm going to simulate some data around this particular thing to create a more minority class data to be created more, and do that. Then you address the remaining aspects. Now, oftentimes what happens is when somebody gives you this particular information, they jump into the model. They say, I will build a model with decision tree, because decision tree is one of the best models in my experience. I mean, big story they will go. But if you try to address this, you will definitely get more brownie points, and they'll definitely be more impressed with you. So that is one trick that you must kind of remember. All right. So next we will discuss about We discussed about Bayes rule, right? So now we'll discuss about k nearest neighbor. Like I said, we are going to be doing with the shallow models. So let us talk about the KNN. Now, is there a logic in the k nearest neighbor model for choosing the k value? Now, trust me, the best of the best people, especially freshers, I mean, people who have just learned the topic, when they go to this, when they get a chance to get an interview and somebody asks them these kind of questions. I have also done this multiple times. The answer that people give absurdly is, we can use the this is the answer that they give, which is absolutely incorrect, right? This is absolutely incorrect. The reason being, this particular aspect of square root of you know square root of n by 2 is for k means clustering and not k nearest neighbor. All right, people still get confused between k means clustering and k nearest neighbor. I have asked them questions, in the last session. If you've attended, I would have asked them, what is can we use clustering for supervised? All right, can we use k means clustering for supervised? And I have had people respond, yes, k means clustering is supervised. It is the nearest neighbor thing. They will start off and then they'll realize there is a mistake. So k means and knn is something that interviewers have fun in, trapping you. Okay, so that is one thing that you may want to be very careful. So what is the logic? All right, is there any logic, or is it always arbitrary? All right. So the choice of the k value is done again by a visualization. All right, again by the visualization of the training and test accuracy. All right, by plotting the training and test accuracies for the various k values, and also looking at the overfit. All right, so how to measure the overfit? The difference between the training accuracy and the test accuracy should be minimal. Now, if you look at the difference, if there can be a random choice by some random means, now ideally what should happen in the case of overfit? Let me just put it here. So, oops, that is, let me just correct that. Okay, excuse me. Train accuracy minus test accuracy less than or equal to 5%. All right, this is the thumb rule. Or if you put it as test error minus train error should be less than or equal to 5%. All right. Now, what if this particular value, train accuracy minus test accuracy, is equal to minus 6.8%. All right. So what is happening here? In real life with certain data, you can get this. Now, if you go by the simple rule of the difference between the train accuracy and the test accuracy should be low, let us say you have a table. All right. All right. You have K, you have train, you have test, and let me put it as accuracy because it is easier that way. Now, when you were to sort this particular data, all right, which is the best value, different values of K. I'm not going to enter these values of, train and test accuracy. I'm not going to enter the train and test accuracy at this point of time. All right. I'm going to directly give the difference of values and I'm going to sort it in the ascending order. So I might get 6.8% negative, all right, 0.34%, all right, then plus 4.5%, and plus 12%. Now, obviously, if you look at this, now obviously we are not going to be looking at these values. Now, whatever the value of K we have, this is the model that has the closest value, that is closest to the train and test are pretty close. But in the visualization, what is going to happen, what you people have learned, in the visualization, you would be tempted to say that this is the lowest value because the accuracy measure, I mean, the difference of the accuracies between the train and test is lowest at this point of time, which is not the case. So you will have to tell them that the accuracy measures are close to 0, or you should not just say less than or equal to 0.5, but less than or equal to 0.5 and ensuring that this is a positive value. Why do you have a negative, a negative value between the train minus test accuracy is a question that I doubt people will ask. But if you happen to mention it, and if the person is actually kind of technical, and if he's kind of getting intrigued, okay, this is also something that the person has, noted. So he'll ask you, why does this such particular situation happen? And if you have an option of, um, uh, probably a piece of paper and pen, and you can actually use that to explain it, then probably it is fine. Otherwise, you say what could happen, I'll try to explain it in a two-dimensional space. So I have the classification model between a bivariate data binary class, and I have the two values, and I have the other color values. It may so happen that my training data could be, could be like this, and this could be my training data. So when I build a model on around this, my model will be something like this. This is the classification model. So where there are bound to be certain misclassifications, all right, misclassification here. So these are the misclassifications. So this may be my training data, and when I build the model, this is the misclassification that I get. However, my test data, so what I'll do is I'll now plot the test data using a slightly different color. So I'll put it in the light blue as my test data. All right, you'll have to. So this is my test data. My test data could be here, and my train data, I'm going to put it pink, could be like this. It could be a random chance that my train data and test data are not proper. So now the training accuracy will have those misclassifications, therefore the accuracies will be less. That is why you see those green circles. Whereas when you look at the same model and you put the test data into it, it is 100% classifying it. So when we have such a scenario, we must randomize the data and do the train and test split in a different way. All right, and then it is a good opportunity to introduce them to the k-fold method of sample selection. All right, what the k-fold does is it does multiple samples, it folds up into multiple samples, and that is why this particular chance of train accuracy being less than the test accuracy is avoided. All right, so that is another aspect that I thought I'll share with you. Again, these are all comes with experiences in the classroom. Okay. The other aspect that is often asked is the choice of the k value. Another thing that you can probably mention about the k value. Is chosen iteratively. K is the k value should not be divisible by the number of classes. All right, the number of classes that exist, the k value should not be divisible. These are some of the rules that we use when we are using the k value, choosing the k value. So if you have, let us say, three classes, three class problem you have and you want to do the KNN model, then choose values 4, 5, 7, 8, 10, 11, 13, 14, so on and so forth. If you have four class problem, then you may want to choose 5, 6, 7, 9, 10, 11, 13, 14, 15, so on and so forth, so that whatever the value is, we don't get it divisible by that. I'm assuming you are all very clear as to why this particular thing is there, because we should not get the scenario of having equal number of classes in a particular neighborhood, and therefore because of that we will equal number of classes in the neighborhood, and therefore we should ensure that there is no the result is not declared by the k is equal to 1. So that is one thing. So that is with reference to the another what shall I say, shallow models, which is KNN. Okay, and next we will see a little bit about the decision tree. All right, decision tree also is considered as part of the shallow model. Now, one of the common questions that the interviewers ask with reference to decision tree is the decision tree's usefulness with reference to continuous outputs. All right, so how can we build how can we get how can we model decision tree for regression is what the question would be, and this is a question that will come maybe as a second question or the third question. So the objective should be that you should lead them, all right, you should lead them to the this particular question towards the end. All right, so one of the things about the decision tree continuous modeling is that while we can predict the continuous output, it is still remains kind of a classification model where we are going to have the continuous values broken down into multiple classes. It is basically a case of binning of the data. All right. So while in reality we are saying it is regression, but in actuality it is basically some kind of the binning method. However, with the probability measures that the decision tree gives, we can still roll back and get back the continuous value themselves. But in prima facie, or as the thing stands, it is predominantly in the binned data, and it is again the continuous data is made into categorical data or binned data. All right. So we have two types of decision trees. One is the categorical variable decision tree, and then we have the what is known as the continuous variable decision tree. All right. Now there are essentially two things. In fact, there are three things essentially, but they are predominantly it is only two. I mean, root is simply the data. I mean, we don't really call that root, okay, unless and until you want to try and understand it in the perspective of what is that variable with which you're going to start the split. That is essentially the root. Otherwise, it is basically the uh, you know the decision node and the terminal node. These are the two predominant things that we are going to be seeing as part of the decision tree. So all right, rules for deciding to on what basis are you going to do the decision, or what basis are you going to split it. All right, so there are various things that we are going to be taking up. Okay, uh, we have the information gain, we have the uh, Gini index. All right, so excuse me. Now as part of the curriculum, you might have all learnt about the information gain computation and how it is there. It is again the information gain is again some kind of a probabilistic measure, right? Is what we have. So Gini index is on similar lines where we are trying to select which of the two. So it is either or kind of an A/B testing kind of an approach. If I were to choose one among them in relation to this, what is the probability of the other? If I were to choose the other in relation to them, in relation to it, what is the probability of the other? So the Gini index also kind of looks at the purity of the class. All right, the measure of entropy also comes into the aspect of it. All right, so we look at the probability of the success and the failure at each of the nodes. So if I have, let us say, a node, all right, if the explanation is required, if I have, let us say, a node wherein it is 50-50, all right, it is 50-50, meaning the probability of the universal method of identifying the probability of success is P, and the probability of failure is Q, or also called as 1 minus P. All right, now what is the probability now? P is equal to 0.5. all right, 0.5, and Q is equal to 0.5. Now the interesting thing about the Gini index is that when we take the square of these values, if these values are close to 0.5, the values will be different. All right, So on the basis of the squared values of these Gini indexes, these probability values, all right. So the Gini index value is basically calculated, and then we apply the Gini score for each possibility. What if I were to do it in a specific way? What if I were to do it in another specific way? All right. And obviously, I'm not getting into the math behind the Gini index calculation, because that is something is you may want to look it up. All right. So the square of the probabilities taken into consideration with the count of the classes. All right. Those aspects also both are taken into that. And another aspect which is also used in the decision tree classification is the chi-square test. All right. We all know what the chi-square test is. Okay. The chi-square test is essentially a test for significance. All right. Significance of the variables. And that is something we will be taking up. Now, this is relatively new. I mean, when I say relatively new, this is not something that has been discussed in great detail, but this is something you may want to take up. All right. So the chi-square test the chi-square test is a method which looks at these, again, the differences between the statistical significance differences between the subnodes versus the parent node. So when you are at a node, call it the parent node, you have multiple ways you can split it. You may decide to choose in one of the many ways possible. Now, when we try to split it in one of those many ways possible or all those ways possible, from the parent when moving to the child in one of those ways or all of those ways, how statistically significant it is. All right, we are able to uh, do it, and it you can probably use this expression like it creates what is known as the uh, chiad. All right, it produces something called as the chiad. Chiad is known as the chi-square automatic interaction detector. All right. Excuse me. So the chiad values will be used to the chi-square test will use the chiad values, which is automatic interaction detector. It will form kind of a tree, and then on that basis we will choose which is the best node and which is not the best node. Now, obviously, you will have to get a little more into the details of it. I leave it to you to research about those things, because again, remember, at every step when you are explaining something, you will have to be sure how much information you are giving, and after that information, how much are you willing to go deeper into it. So if you try to explain something in great detail, okay, this is very easy, and if you show some enthusiasm, obviously the interviewer is going to probably cut you short and try to understand it in a different way. And if you try to explain something in less detail, interviewer is going to test you onto that, because intuitively interviewers try to put you in a tough situation. They want to see how well you perform in such a tough situation. So therefore you may want to um, choose the topics that you are thorough to reveal less. All right, when you reveal less about a topic that you're thorough, then automatically you will be asked to explain more, and then you will be in a much better position to give the answers. So that's something that is there. So we have information gain, we have the Gini index, also Gini index sometimes people say, and we have the chi-square test through which we decide um, you know what way we are going to be doing that. There are various other methods also, but that is um, not so popular. There is one more method which, on the top of my head, I remember is about reduction of variance. So you calculate the variance in each node. So that is again, the simple logic is, if you are at a particular node, let us say if you are here and you have multiple options, option 1, option 2, option 3 for splitting. For each of those options, that is even before you split it, you try and find out what would be the the variance between that particular node, and try to go for a scenario where the variances are as less as possible. That is called the minimizing of the variance measures. All right, reduction in variance. Now, reduction in variance is obviously something that automatically is only useful for continuous data. All right, and obviously in the nodes we are going to have only the sorry, my bad. When we are talking about the reduction in variance methodology, so the reduction in variance, the measurement of variance is possible only for continuous values. Now, what do you mean by continuous values? I mean the variables that are the numerical values that are continuous values. All right, the input variables are continuous variables. Meaning which that when we are looking at decision tree, one of the prerequisites of decision tree is you need to discretize the data into various bins. I mean, when I'm talking about the I'm talking about the input various input columns. So you need to make them into discrete entities. Now, if you're making them into discrete entities, then the concept of variance doesn't work. But if you retain the values as is, as numerical values, and whatever way we split it, all right, and if we look at the measurement of the variances of each of the nodes, then that is another method of working with decision tree without discretizing the case. All right, so that is an important aspect that but we need to look at it. Now, another aspect is, what are the disadvantages of decision tree is a common question often asked. Why decision tree? And trust me, it is my understanding and it is my experience that many students, especially freshers, when you ask them what is your favorite supervised algorithm, their favorite supervised algorithm is decision tree. Somehow that is what they always invariably say. So you should be thorough and completely prepared about decision tree. So there are no problems in decision tree. What is the problem? So one of the common problems of decision tree is the problem of overfitting. All right, so what is it that you do to avoid the overfitting? One of the common things to respond is we do pruning. All right, we remove subnodes of a decision tree. This is called pruning. Basically, it is considered to be the opposite of the splitting process. All right, we are trying to split it further, but we are actually preventing the split further. That is what is known as pruning. So how do you what else are the methods of avoiding the overfitting in a decision tree? All right, so you set the constraints. All right, before even you get into that, you set with how many levels are we going to go. Are we going to build the tree completely, or are we going to stop the tree after maybe 3 or 4 levels? Even if the classification is not complete, it's okay. Now, remember that decision tree is an algorithm that is best suited when the number of input variables is large. It doesn't make sense for 6, 7 input variables to go for decision tree. All right, various other classification algorithms will more than easily work. All right, so when you have really large number of at least 20, 30, 40 such input variables, decision tree kind of makes sense. And when you have such really large variables, the tree will have to grow. I mean, theoretically the tree has to have that many splits. Imagine the entropy is, the information gain at every node is the lowest possible. So if there are, let us say, 20 nodes, then you will have to have 20 times the tree splitting, minimum of 20 times, at least 20 times the tree needs to split. It can be less, all right, approximately. So if it is going to have that many levels, obviously the tree complexity is going to be more, and obviously the overfitting problem is going to happen. So you may decide what stop at 15 or 20 or 12 or 13 or whatever, all right. And then um, you know you can also choose the maximum number of samples for a node split, minimum number of samples for a node split, all right. uh, what is the minimum number of samples that you're going to have in a particular terminal node, all right. And of course I was talking about the vertical depth, the how deep, the vertical height or vertical depth of the uh, trees that you can have. You can have a lot of other parameters, like I'm going to have only a maximum of so many terminal nodes. If a tree is going to get split multiple times, each of those branches will need that many terminal nodes to be created. So you'll have 30, 35, 40, 50, 60, 70 such terminal nodes. You may want to probably put them. uh, okay. And but the biggest or the easiest approach to addressing the decision tree is, this is more of a theoretical answer, all right, that when we are dealing with decision tree, while it is good to have, decision tree is good for really large number of input variables, and those input variables will be easily used for classification in a decision tree. It is always important to spend a good deal of time in EDA. All right, these are some of the things that definitely impresses the people. It is always important to spend some time on EDA, and in the EDA, find out if there are certain variables that can be ignored. There are some irrelevant and to our output variable of interest. If we can, ignore those variables and then uh, remove them, we can do the, you know, trimming, not pruning. We can do the trimming beforehand. That will also avoid the problem of overfitting, because if I'm going to use all the variables, obviously the tree will try to address all those factors, and addressing all those factors will tend to have a overfit. All right, so that's basically what is something that is with reference to reduction of the overfit problem. Then you may want to discuss a little more about the tree pruning. Uh, so then a little bit of theory with reference to pre-pruning and post-pruning. All right, how does it? What is pre-pruning, and how is it different from post-pruning? Pre-pruning is we don't nip it in the bud, we don't even let it to grow. All right, so in theory. And post-pruning is we let the tree grow, and then we find out where are these additional branches, and then we cut them off, all right, wherever it is there. So that is essentially what it is. Okay. And what is the, with reference to the code part of it, all right, you may want to also have a little grip on that. What is that packages for the purpose of pruning? What is the packages for the purpose of all these aspects? So my recommendation is obviously go for Python. Always go for Python in these kind of things. All right. And how do we do tree pruning and all that? So recently, we've come to know that sklearn and decision tree classifier. Right, in sklearn we have the classifier models, the decision tree classifier. It is not supporting the pruning part of it. All right, that is something that is not part of it, and therefore you will have to probably go for some XGBoost kind of applications. Uh, and then within that you will have to probably, though you may not use the XGBoost kind of things, within that you will have to do the pruning. So to summarize for today's session, what I would recommend is, as a part of your preparation, pick one single topic by the day, let us say for KNN, and then try to get into all the possible depths, that with depth, all those things. All right, and uh, one is when you watch let us say a fiction movie. All right, I'll use this analogy because I learned it from my son. So the first time you watch, let us say, Avengers or any of these movies, it is nice, feel it great. But if you are a very big fan of the Marvel Cinematic Universe, or if you're a very big fan of any of these action movies, the next time you watch, you look for what is known as the Easter egg. You look for what is known as, did the producers and the directors make a mistake? Where can I spot those things? What is that on the background? All right, how can I find those things out if you are in the habit of that? So what I want you to do is, when you are revising the topic, it is very easy and very convenient to quickly, yeah, this I know, yeah, fine, this is fine, this is fine. Take a pause at every position and try to find out, what is this? Try to question it. Something is missing here. If anything is missing, a what if kind of an scenario, and definitely you will be in a better position. What we are doing as part of this exercise is to show you those multiple scenarios, of those what if scenarios, what we have seen. We have not seen everything in the world. Right, so please do that also at your end, and obviously that will go a long way. So on this note, I would like to stop the session and wish